Welcome back, mathematicians. In this lesson, we're exploring inverse functions, how to reverse a function, and figure out what input creates a given output. We're going to go through 3 examples and simply find the inverses of each. The 3 examples start off relatively easy and get more challenging as you go. This one is a linear equation. This one is a quadratic. And this one is a rational function that takes a little more algebra to untangle. If you'd like to skip to any one of these more challenging equations, feel free to check out the chapter links in the description below. Let's get started. This first function is a linear function, and I'm using this simplified function in order to show you the step-by-step instructions for how to find the inverse before we get to the more challenging equations later. So we like to tell students that the very first thing we're going to do is simply rewrite this equation using y instead of f of x. Remember that when we first started graphing equations like this, we used x and y as our 2 variables on the coordinate plane, and then we would graph. We moved to function notation in order to make things more flexible. We can have multiple functions that we work with. So we're going to go back and forth between y and f of x. So that's our simple first step. Change f of x into y. The second step is pretty simple too, although it's difficult for students to understand. So I'm going to explain with a coordinate point. It kind of seems like magic if you just tell students that you're going to rotate these 2 functions, but what you're actually doing is finding the inverse by flipping the function over the graph of y equals x. So all we're really doing is replacing all the x's with all the y's. So if we have a coordinate as part of the function that's -1, 0, its inverse is going to be 0, -1. And if you put these functions into a graphing calculator like a handheld or Desmos Online, you will see that what's happening is you're creating an exact mirror image of it reflected over the line y equals x. The math of this, though, is rather simple. Like magic, all we're going to do is flip the x and the y, where the x and the y are located. So instead of y, I'm going to write x, and instead of x, I'm going to write y. Now I have to solve for y in order to turn it back into function notation. So my very first step is going to be adding 5 to both sides. That means on this side, I have x plus 5, and on this side, I have 3y, since that cancels. Now to get the y by itself, I'm going to divide both sides by 3. Remember that when you divide by 3, you need to divide everything by 3. And while we could do 1/3 x and 5/3, I find it much easier for my brain to look at it this way. That's going to cancel out the 3's, and what I'm left with is y by itself equals x plus 5 over 3. Remember, I can use the symmetric property of equality just to flip those around. So my final answer is going to be written back in function form with one exception. We need to put a -1 in the exponent spot here in order to indicate this is not f of x, this is the inverse of f of x. And that's the final answer. Let's move on to one that's a little bit more challenging. In this quadratic, you can see that the domain is restricted. The reason that that domain is restricted is so that both functions will end up being 1-to-1. If we were to solve this just on its own without the restricted domain, when you get to the end of this, you would be able to say it is not 1-to-1. It has to have a domain restriction. That's not important unless your homework or your teacher is also asking you to find out whether or not these 2 functions are 1-to-1. The work itself is going to be the same, just a little bit more complex. So first we're going to turn f of x into y. And just like last time, we're going to change the x and the y with each other. Everything else is going to stay exactly the same. The easiest way to unlock this y that we have to solve for now that's behind a square is to take the square root of both sides. Remember that a square and a square root cancel each other out. That leaves us with the square root of x equals y plus 4. To get rid of the 4, we're simply going to subtract it from both sides to cancel that out. And we're left with y equals the square root of x minus 4. We can rewrite this back into our function notation with our inverse notation. The inverse of f of x equals the square root of x minus 4. And that's our final answer. Let's go ahead and tackle this rational expression. Just like all the others, we're going to change f of x into y. Now I'm going to leave myself a lot of room here because this gets a little bit long. Remember that what we're doing is replacing every x with a y and every y with an x. So instead of writing this y, I'm going to write an x. Everything else stays exactly the same. Now we need to do the work of getting y by itself. In order to do that, we're going to use cross multiplication. Cross multiplication is when we take the numerator of one side and multiply it across to the entire denominator of the other. I've turned this into a fraction by putting it over 1. Remember, all whole numbers, or in this case, whole variables, are over 1 in order to turn them to a fraction. That means that this x is going to multiply the entire expression y plus 1. And it means that this 1 is going to multiply this entire expression 2y plus 3. Now that's not technically going to change that side, but I want to leave it this way in the notes so that you can see what cross multiplication looks like. Now I'm going to distribute. X times y is xy. X times 1 is x. 1 times both of these things doesn't change anything. On your paper, of course, you would keep going, but I'm going to rewrite what I have so far for the function up here, so that I have some space in order to start solving for y. To solve for y, I need to move all my y's to one side and everything else to the other, so that I can factor out a y. So I'm going to subtract 2y from both sides, like this. On this side, that leaves xy minus 2y plus x equals 3. Now I need to get rid of that x by moving it to the other side with subtraction. What I'm left with is xy minus 2y equals negative x plus 3. Now I have a y in both terms that I'm able to factor out. Remember that factoring means you're dividing both terms by the same thing that they share. So we can move a y out to the front of a parentheses. Y over y is 1, so that leaves x. Y over y is 1, so that leaves minus 2. And this side is unchanged by this action. So finally, to get y by itself, I am going to divide by x minus 2. Remember that anything over itself is going to be 1. So that gets rid of this. That leaves my y by itself on this side, and it's equal to negative x plus 3 over x minus 2 over here. This is what I'm going to rewrite back into function notation. So the inverse of f of x equals negative x plus 3 over x minus 2. And that's our final answer. Don't forget to like and subscribe down below and post any comments if you have questions or further equations you'd like me to solve.